Welcome to this edition of India Means Innovation, where we discuss the technologically complex innovations coming out of India. Today we have with us Mr. Kamal Sethi, who heads the Center of Excellence for Autonomous Driving at Quest Global. Welcome, Kamal.
Thanks, Aditya.
Kamal, before we get into this wonderful innovation that your team has created about replacement of expensive LiDARs in autonomous driving cars, can we step back a little bit for the audience and discuss the levels of autonomous driving? You know, we call it L2, L3, L4, L5. So what's the difference between L2 and the jump to L3 from where real autonomous driving starts?
Look, when we talk about L2, okay, we are talking about ADAS, we are talking about Advanced Driver Assistance System. In the nutshell, what we say there is, you are driving a car where a driver has to have a mind's on, hands on, and eyes on. It means car software is having certain sensors, okay, but still the eyes, hands, and drivers need to be always attentive up to L2. Another thing is L2 will only drive longitudinally. So the software is only doing the longitudinal stuff. For example, in adaptive cruise control, right? You are only in one lane, you go there, brake, speed, throttle, brake, speed. That's what you do in case of L2. The car software does, right? And when we talk about L3, we are actually saying hands off, eyes off, but mind on.
Okay.
Okay. So now this is an interesting phenomena where car software gets an additional flexibility. Okay. Because now car software can not only move in the longitudinal direction, but it can also take the latitudinal one, switch lanes. It can autonomously switch lanes. Okay. But when car software sees that there are some issues, based on that, it gives the control back to the driver.
Only when there are
Only
issues.
when there are issues. Yeah.
When you say at L3 level, eyes off, hands off, so the driver doesn't need to use his or her own eyes. The car has eyes. And these eyes of the car are a combination of LiDARs, cameras, and radars. Now, how and why would you want to replace the LiDARs?
Look, what we need to understand is one, LiDAR is an expensive still. So it's a bit expensive as compared to cameras and radars, which are predominantly comes around $80 to $100. I can increase slightly on the software complexity side because now I have enough compute in my car. So I can take a leverage of that processing chip. I can reduce the complexity of additional sensors like LiDAR. I can reduce the complexity of large data capturing offline, but rather I can actually move into an entire gamut of online space where I have less sensors and I have a little bit additional complexity in the algorithm because now I have additional TOPS available to me and I can do perfect same autonomy which I can do it with LiDAR.
So when you replace the LiDAR, you replace it with a combination of cameras and radars. Now, has there been an advancement in radars? Have 4D radars come in?
Around 5 years back, we were only having radars which were 3D radars. Okay. Now in the 3D radars, the space where we were missing was it was not giving me the height of the objects which are in front of me, for example. And the data it was also giving me was a sparse data, whereas your camera generally gives you dense data. Now with the new evolution of 4D radars in last 3 years or 4 years, now I am getting the additional height of the objects as well. So now I am getting much denser data, which is somehow equivalent to how LiDAR gives you the data, which is even more denser, but what it actually additionally gives you is the height of the objects as well.
So not just on the longitudinal scale, but also on the vertical scale?
On the vertical scale, yes.
Yeah. So the eyes of the camera are far more effective with a combination of 4D radar as well as the cameras.
Yeah, eyes of the cars.
Eyes
are,
of the car.
Yeah, now it's much more robust because now it is getting additional information from cameras and additional information coming from 4D radars.
What about the range of these sensors?
Cameras generally comes with different megapixel levels, but I will simply make it down that it can still able to process the information up to 80 meters to 100 meters.
Okay.
Camera can actually see infinity, but actual brain processing it happens up to 80 meter to 100 meter depending upon which megapixel I am using for cameras. Now 4D radars can easily see up to 250 meters to 300 meters, and LiDARs again same way it can see 100 to 150 meter. So eventually I am getting the same efficacy in terms of the range, I am getting the same, slightly better from a combination of cameras and radars.
And based on the information that comes in from this combination of 4D radars and the cameras, the software creates a map
Yeah.
on its own. Does it require additional maps? Does it require Google Maps?
Let's understand from the two perspective there. First, LiDARs actually was dependent upon the HD maps. Okay, so HD maps are an additional map where I am getting an additional information, positional information onto my map. What that additional positional information I am getting is how many lanes I am having on my road, on which side I am driving, how many lanes I am having. It's a 2-lane, 3-lane. What are the precise locations of those lanes? Where are other stationary objects on the road? For example, traffic signs. Where are the static traffic signs are placed? Where are some other traffic lights are placed? So I get that additional information, but I need to comprehend this additional information or process this additional information offline, right? That was the space of HD map and LiDAR.
Okay.
Now, with the advent of cameras plus 4D radars, we need to add on slightly additional complexity in terms of the software, where we are calling it as a mapless driving. Okay. Now, this mapless driving is where I am adding additional software complexity from my sensor perceiving, how I am perceiving the environment. I am creating a dense perceiving environment or top view of my environment. And additionally, what I am relying on is standard map data which is available in the car. So we already have in our car the standard maps available, right? So I use only those standard maps, SD maps, we call them SD maps. But I will use an additional complexity in terms of software to understand what are to localize myself and to understand what are my standard positional elements on the road. For example, where are my lines, where are my other traffic objects like traffic sign, and based on this additional complexity in the software and sensors information, I will try to localize myself.
Also with respect to the other vehicles on the road, so this combination of camera and 4D radars, front, back, side, they should be able to figure out the other vehicles which are moving on the road, their speed, how far away are they from you, can the software of the car give a go-ahead for switching lanes based on the moving cars on the road.
Yeah, that's true, Aditya. So that's what eventually we are doing. So when actually we drive, how we generally drive, we see left mirror, right mirror, and then we see that there are any things, because my generally driver field of view is only front, right? We have a 52-degree or 50-degree field of view roughly, horizontal field of view. So we just see in front. We can see front lane, next lane, next to next lane, but we always focus front. And then we have an additional thing which comes from the side mirrors. We see left and right. Now this entire thing which I am trying to visualize it in my viewport as a driver, I want this additional information via the eyes of the car. And that eyes are nothing but sensors.
What are the technologies that your team has used to create this innovation of mapless driving?
Okay, so from technology perspective, as I mentioned earlier, we are using long distance cameras where I will have a 80 to 100 meter range. The perceived range in terms means where I am actually detecting my object space. And this is around 360 degree. So surround view, as just now you mentioned, it only gives me up to 10 meter or 15 meter range, but I need cameras which can see far. So I am able to have 80 meters surround view. Additionally, I have an additional sensors also, which are my radar space, where I am actually getting a additional complexity of position and velocity of each vehicle which is there around me. in the 360-degree view
Right.
with my 4D radars. On top of it, I also use the wheel odometry, because what I now next I need to do in 3D is to localize myself, to say that on which lane I am driving, not on which side I am driving.
Right.
Right? In L2 we say on which side we are driving. In L3 we say on which lane now I am driving, because I have to change my lane dynamically, right, any point of time. So for getting that precise additional information, I use the map which I have generated, means the object map which I have generated through my sensors, which we call as perception map. The second, we use the additional information which is already there in the car. For example, the GPS map, which gives me that on which lane you are driving. Third thing, from the perception map, I try to visualize the things where, for example, how many lanes I am having in my side. Okay, where is my other stationary objects like traffic light, right? And I use the vehicle odometry as well, wheel odometry. So I have the sensors on the wheel, which actually gives me the wheel odometry specifications. And additionally, I am having the IMU sensor. IMU sensor is nothing but an inertial measurement unit, which gives me yaw pitch roll of the car essentially. So with all these specific sensor suite and complexity which I have added in my perception layer,
Which is in the software.
which is in the software side, right? Based on that, I predict that on which lane my car is at this point of time, and whether I will able to take an action, that whether I can now switch my lane from this lane to left lane or from middle lane to right lane.
Digital is driving the advancements of cars, and India has become the digital capital of the world. And this entire innovation has been done by your team in India.
Yeah.
Can you talk about the mindset of innovation that you get your team into, instead of, working towards someone else's specs?
When I work with an engineer, it actually comes with different set of mindsets. I say to my team, look, at the end of the day, what we are doing is we are saving the lives of the human beings which are on the road. Right now the statistics shows, and this is the WHO figures, we are having every year 1.2 million deaths
Globally,
globally
in car accidents.
in car accidents. And that's astonishing.
And this is because of mistakes made by the driver, fatigue of the driver,
Yes.
inexperience of the driver.
So 30% of such cases are because of driver fatigue, plus driver is not attentive. So these are the huge numbers, astonishing numbers. And we can easily reduce this to this extent via using advanced softwares like ADAS or autonomous driving softwares, where we can rely more on the vehicle software rather than relying on the driver.
The sensors and the software don't get distracted. Sensors and software don't get tired and fatigued.
I am firm believer that if I am able to drive in India, I can drive anywhere in the world, right? As a
Absolutely.
driver, right? If my team develops something within India, they can scale it to outside India. That's very clear. And the innovation seed which right now they are having, or the pump up which they are having, is they are so passionate about this particular technology. They are so passionate about how I can bring a change in the world.
That's wonderful. It's a great example of India means innovation. Thank you so much, Kamal.
Thanks. It was nice discussing with you.